So welcome everyone to another Streaming Stories panel. Really great to have you all here. Today we're going to talk about real-time Gen AI, whether we are going to reinforce the buzz or debunk the myth. I'm really excited to hear what our panelists have to say on the topic. And today with us, really amazing 4 speakers: Kai Vene, Global Field CTO at Confluent; Neng Lu, Director of Platform at Streamnative; Rong, Member of Technical Staff at Character AI; and Raiz Pasha, Head of Product at RisingWave. Thank you once again for being us today. I'll let you introduce yourself a little bit later. But before we start with the panel, just like a few housekeeping items. So all participants are muted other than panelists, but at any moment you can ask your questions or share whatever you feel like sharing in the chat or use Q&A tab for the questions. The webinar will be recorded, and if you have any issues with the Zoom, feel free to ping me or my colleague Zach. And yeah, we can move now to the official part, and let's start with the panel. So let's start with the first question. And feel free also to tell a little bit about yourself and what you're doing. So the first question would be what are your views on real-time Gen AI? And how do you feel about this relationship between data streaming and Gen AI? So I have you on my screen, so I'll start with Kai, and then we'll have all of you.
All right, I can start and then others can add to that or also, of course, disagree with some of my comments. But maybe in the first question also for the introduction. So I'm Kai with Confluent. I worked with Confluent for over 7 years now, which is a pretty long time for this company and also the technologies behind that like Kafka. And in the end, I also work in the AI space for a very long time, especially because I support our customers deploying AI in production. And I think this is the same now what we see with generative AI as one subcategory, because using Gen AI is straightforward. So I'm using it on my iPhone every day instead of Google search for many use cases already because it's so good in that. But obviously, it also has a lot of challenges. And this is exactly where I see now our customers adopting data streaming together with Gen AI to solve real world problems, which is a much, much more complex problem than just using something like ChatGPT or any other large language model. And I will talk a bit about more concrete customer examples or use cases later. But in general, as an introduction, I think the reality is for AI and then specifically also Gen AI that you need to have up-to-date information in the right context. Otherwise, Gen AI will hallucinate. Hallucinate, that means that it gives you wrong answers. And this is exactly where data streaming fits in because it can provide the right context so that your generative AI application can give the right answer or prediction or whatever you expect to get from it. And that's in the end the short answer why I see really the relevance of real time for Gen AI is so important. And this is really underestimated in enterprises because using, again, just ChatGPT or similar is a very different use case than really bringing Gen AI into your production use cases.
Thanks, Kai. Raiz, want to go next?
Yeah,
Sure.
I think I can go. Oh, sorry.
Sorry.
Yeah. Oh, do you want me to go? Okay. Yeah, hi everyone. My name is Raiz Pasha. I head the product team at RisingWave Labs. RisingWave Labs is a fairly young company. We've been around for 3.5 years. Our core product is a stream processing database. So, in a logical sense, we are sort of the plumbing behind a lot of the AI workloads that you see in terms of incrementally improving the models through data preparations. And then also some of the use cases RisingWave has been used for more feature store functionality. The conversation around Gen AI is interesting because the whole RAG framework about how to augment Gen AI for more private data for targeted domain specific use cases is an interesting opening for us as a beachhead, I think. And I think over the course of the conversation, I'd like to discuss what are the specific use cases where we see a streaming database like RisingWave can help augment especially large corporations who not only want to get the functionality what is provided from LLMs out of the box, but to actually use it in a meaningful, domain-specific way to solve problems, like really hard problems. Yeah, looking forward to the conversation with everyone here.
Thanks, Reese. Nang.
Yeah. Hello, everyone. Thanks for having me here. And my name is Nin. So I'm currently the director of platform at StreamNative, and I have been working in the streaming area like for many years. So that like my background is more like traditional data streaming infrastructure background. But recently, we're seeing like more and more people are getting into interest in the GenAI case. And from my understanding, data streaming and like data processing is kind of the foundation of the infrastructures for all the like different kind of use cases. And nowadays we're having this GenAI new area or new like use cases opened like GenAI. And I think recently like people just like solve the problem, like the first step, that is what we have for what we can do with the GenAI. I think as the need grows and as we evolving, like we will next in the next phase, we will be probably like solving the question about like how we can capture most of the most recent data and the most effect data. And I think that's where like the streaming technologies can actually be helpful in the GenAI world, in the GenAI cases. But yeah, but we can discuss more in the following discussions.
Thanks, Nang. Rong, want to go?
Yep. Hi, my name's Ron. Hi, everyone. I'm currently MTS in Character AI. So I have been working with sort of like an ML platform and data platform for like a little bit over a decade now. So majority of the use cases that I actually supported previously is actually been jumping from kind of like a traditional microservices to data analytics to more like kind of like a current large language model structures. Currently, I'm actually working on the research platform for Character AI. So majority of the use cases that we currently do is actually kind of like supporting the research needs as well as some of the production needs. My answer would come quite from a little bit of a different angle because a lot of the times when streaming solutions coming in here would probably affect not just the production, but also in terms of other research related stuff such as experimental platforms, research analytics and such like that. So basically, the use case for streaming goes not just beyond production use cases like inference, but also can be super helpful in a lot of like other use cases, right? Such as experiments, A/B testings, etc., etc. So we have been seeing like the streaming use cases being super helpful in a lot of these cases. And yeah, actually, this is going to be super interesting to discuss a little bit more because we like to use a lot more streaming solutions in general. But I would actually see this kind of like a trend in terms of like the previous use cases like microservices and data analytics that is basically geared from the batch use cases towards more streaming and then towards more real time. So it's kind of like following the same trend over and over again. It's kind of like super exciting. Yeah, happy to discuss a little bit more on the detailed questions. Yeah.
Thank you, Rong. So some of you kind of briefly tackled on how GenAI is used today, but can we like deeper dive into like some real world use cases? Any examples where you feel that GenAI brings like a lot of benefits?
Yeah,
So
I'm happy to start with that. So I can tell you a little bit about one of my favorite customer stories, which comes from Expedia, which I think many of you know. This is where you book your travel and holiday, like with flights and hotels and so on. And actually, this case study is even before the ChatGPT and similar tools were on the market. So it was during the pandemic when, as you can imagine, Expedia had huge trouble because they had to cancel all their flights, all the hotels. And you can imagine 10, 20, 30x more calls to the hotline. So they were in trouble because And we all experienced that we had to wait for hours on the hotline, right? And the only thing we wanted is a refund or a rebooking. So all the same very simple task, but Expedia needed to respond to that. So during the pandemic, they already had the data streaming platform to connect to their booking engine, to their loyalty platform, to all these systems. So this was already integrated in production. Still, they had this customer service issue for doing refunds and rebookings. And this is then where they trained their own chatbot. So that's what now we call large language model. At that time, they called it a conversational chatbot, but it's the same thing. It was not as good as ChatGPT is today, but it was good enough for that use case in that specific domain. And they deployed this chatbot and connected it via the data streaming platform. And then in the end, they just had to do a slight change in the business process. They kept everything like before, the integration to the booking system, to the loyalty platform, and so on. But then the first inquiry from a customer went into the chatbot instead of directly to a human. And the chatbot, because most of the questions were about a refund or a rebooking, could take over of that. And this also shows how generative AI can help here, not just by answering a question, but by really deeply integrating it into the operational systems of the infrastructure. And it's not a completely new implementation or a big bang. It's really by just integrating it in what already exists. And this is really one of these really successful case studies. And I can give you a few numbers here even. So, and this was after the pandemic where they announced this case study where now they said 60+% of travelers already were self-servicing in chat today. So 60+% were automated via generative AI. 40% plus saved in variable agent costs by enabling self-service via generative AI. And with that, then they support a lot of these bookings and transactions. And this is why this is one of my favorite use cases, because it's not just about training a large language model to give you an answer to your question, but by directly feeding that response of the generative AI back into the transactional systems. Like, for example, doing a rebooking in another booking engine, which is a transactional behavior with payments behind it and so on. And this is an example I wanted to share. And this is where really data streaming is perfect for that, because at its core, it's decoupling everything, it's scalable, it's real time, it connects to operational layers, but also to analytical layers. And now generative AI is in the end one more step you add to that. And obviously, and others can talk more about that today, but then with RAG and other patterns, this is also complex, of course, in itself. But this is in the end how you can really add the value by integrating it into your enterprise architecture. And you're muted, Giovanna.
I am. Thanks. Thanks, Kai. Neng, do you want to go next?
Yeah. So yeah, we recently worked with our customers to empower their GenAI use cases. So I would like to share some of the observations I have here. So when we look at the GenAI or the mostly like the LLM strengths, right? Its ability to summarize the knowledge, summarize the information is actually one of its biggest like advantages. So what our customers is recently doing is like they are utilizing the LLM models to help with their marketing product, so that whenever like they get some kind of event or get some kind of registrations from their front end, the LLM models will be notified about the event, and they will searching into some kind of a knowledge databases to match whatever the email domain from this customer they have, and providing like augmented with additional informations, so that the end users of their product can actually see like who is this customer and what are the basic informations and what are the potential like areas that the customer will be the user will be interested, and how confidence is that this customer would be like interested to purchase your like product. So they're using this whole pipeline to analyze the customer register users information and provide guidance and provide information for the actual users to see like where they need to spend their sales effort. So that's kind of one kind of use case. And another kind of use case I see is more about like internal knowledge base, or like a customer support, smart customer support agent. So what we have here is actually, the LLM model can actually provide a general information, right? But for like any organizations or for any like large corporations, they have their own like evolving like internal knowledge base or involving like documentations. So what we have here is actually, as like the company, as the organization generating more and more knowledges and more runbooks about every aspect of their own internal process or product, the model, they have this deploy this like real-time pipeline to actually updating the models using the RAG architecture. Like this is also real time, so that whenever like this is the new page, new knowledge page, new content that was published, their model or their like a customer facing agent can actually already like react with the customers with the newest information. So these are kind of really like where like the streaming and the real time infra can empower in GenAI in a way that's like it's also both powerful and also can provide like timeless and fresh data. So these are some of my observations for the real world use cases.
Thanks, Nang. Any examples do you want to share, Rong?
Sure, yeah. I mean, like a lot of the use cases that I actually experimented with is more geared towards how to research and basically trying to answer the questions on how to actually get the models to do better jobs in specific domain. But one of the use cases that I personally actually experiment in my home, like kind of like before I even joined Character, was actually pretty interesting. I guess a lot of the audience here probably can actually just try it out and see if it actually works for you guys. Basically, in general, if you consider large language model, right? So they are basically just trying to kind of like gather all of the knowledges in during their training time, and then basically trying to inference what exactly is the most appropriate answers for the next like a couple of seconds. So a lot of the cases what we are trying to do here with the real-time information is trying to augment the larger language model to basically aid it to do a more informed decisions to basically predict what exactly is supposed to be the answer next. What we actually experimented previously is trying to see how these real-time data can actually be incorporated into the model. So one of the examples I think a couple of like the panelists already talked about is RAG. So basically like augmented generation. So you actually put all of these like real-time informations in the context and trying to put the large language model into use to basically trying to get the answers specifically tailored towards the context that you actually put in. In majority of the experiments that I actually ran, this is actually the most effective use cases for streaming data in large language model, right? We're trying a lot of other things. For example, we're trying to do supervised fine tunings on some of the smaller data sets just to basically trying to tailor the large language model to be able to actually gain new knowledges. Surprisingly, it's actually pretty hard to actually ask large language model, especially the larger like open source models. So if you think about the recent Llama models that we basically being generated, it takes significant amount of data that we're actually trying to use in order to basically modify its behaviors in terms of the like kind of like a post-training phases. So we try that. So basically, generally speaking, a lot of the times when the real-time data actually basically needs to fill in is sort of like wanted to basically trying to get how it can actually use those informations instead of actually trying to tailor it to basically do it. So a lot of the production use cases that I currently use is mainly on that area, but it doesn't actually discount the fact that a lot of these real-time informations capture knowledges that you will never be able to see in your training time when your live language model actually is being like produced, right? So there are a lot of potentials, but there are also a lot of research hurdles. So basically trying to see how we can actually incorporate these informations into kind of like letting the model to retreat beyond the context length. But yet another aspect of this is kind of like if you look at the recent trends on Cloud 3, GPT-4o, and all of these other newly released models, the context length actually is becoming more and more insanely long, right? So it's kind of like millions, or if not like tens of millions of like tokens length in terms of context window. So in terms of like how we can actually basically trying to retrieve these informations, it's going to be super interesting to see we can directly feed a lot of these streaming data, just like basically just lump them into the context and trying to let the language model go on work of it. So you don't really actually have to worry about the context and space issue. So all in all, I think like a lot of the use cases that we actually trying to experiment here is sort of like basically proven that the more recent the data is, the more new information that the streaming data actually can carry is the better for generally a lot of the large language model inference production use cases.
Thanks, Reis. Any example?
Yeah, I think in terms of the examples, some of them have already been mentioned. Chatbots, AI chatbots, those are the ones come to mind first. But I think we're just scratching the surface at this point. Anything to do with customer 360, like recommendations, anything personalization, are a natural fit for this. And I think in my own experience with talking to customers who are trying how to take advantage of their existing applications and enhancing the GenAI with some private data. For example, at the end of the day, for me, the distinction between GenAI and real-time AI use cases is they're fundamentally the same, except now with the real-time GenAI, you are augmenting context and private data that was not available to the model, right? So how do you make that available? And how that exponentially increases the value of the use case. Like recommendations has been there for a while. Now, with the fact that you have ability to influence those recommendations using this large model that can give you a vast amount of data. And same thing with, like, say, another example is personalized medicine, right? Personal medicine has been there. It's a hard problem to solve. Now, with the LLMs, instead of having to do the research and getting information about a specific patient, and like relying on all the corpus of data that's there, like WebMD, others, and then joining it with your private data that's in specific to the patient, and providing a much more meaningful, recommendation or profile of a complete picture of a patient profile are the sort of problems that the real-time GenAI would solve. As a data based practitioner, for me, it translates to more a data engineering problem, like on the integration side as well as on the governance side. How do we solve that problem? And we don't have to reinvent new use cases. I think the existing use cases are the ones that get exponentially better because of this real-time nature of the data that we are able to augment. I think the one example that I can leave you with is it's more how we are using, for example, one of the LLMs, right? In our day-to-day operations. For example, we have a bot that we use for customer service on our Slack channels. It's been very highly effective, right? And for me, the reason why it's been effective is not just because it's able to answer problems based on a snapshot of information that we have provided to the LLM, but it is learning as we go. For example, it's learning from Slack conversations, it's learning from the GitHub repos, and whenever there's a change happening in an issue, when a customer asks that question, the LLM is able to read and update based on the current information about particular issue, whether it's in development, it's in ready to be released. So that level of response that you would require a human to actually go triage and figure out an answer, it's doing it automatically. That's a huge productivity gain, I see. Now, the problem is the productivity gains can only be done to a certain extent. How far do we go in terms of providing more intelligent apps, right? Where we can actually replace entire processes built with a custom process with these generalized models is sort of the new frontier in terms of use cases.
Thanks, Raiz. Can we a little bit talk about the technology, the underlying technology? What do you think is the essential technology for building real-time GenAI applications? Maybe we can reverse the order, start from wrong, maybe.
Yeah, sure. So actually, that's a pretty good question. I'll probably answer this question in kind of like a research platform perspective. It's a little bit geared towards how we actually think about like building kind of like a research platform specifically and what technology that needs to be done there. I think like the other panelists probably can answer this question in a more production scale. A lot of the times that when I actually think about technologies that needs to be done on kind of like how do you like I think the goal here is sort of like for the researchers kind of like how can we build a more intelligent large language model, right? So the technology that is essential for this is obviously how you can actually manage this your GPU fleets, your kind of like your accelerators. How do you actually build your machine learning inference or like training platforms? Obviously, and then the most important thing afterwards is kind of like after the infrastructure is being set up, how do you actually pump the data through it, right? So obviously in this time, the data volume is more important comparing to when we're actually trying to train the model, comparing to production. But one of the most important things that I actually realized, like I've had like certain amount of like this type of research like efforts is reliability and kind of like consistency for constantly like new data that's actually being like put into the research is actually the more important thing compared to can you actually pump data faster or in terms of latency. So in that sense, like I think like we leverage a lot of like streaming technology specifically for this manner. It's kind of like you have a reliable stream of data that can actually being pumped into your data lake. It's replayable, reprocessable, and kind of like one of the things that I realized that on the data world is kind of like the deterministic sum for how you actually process stream data is more important because like God forbid that like a lot of the large language models kind of have a lot of like non-determinisms, specifically how you actually structure the data, how you actually like clean the data, and how you actually make more data more important compared to the others, right? So a lot of experiments are actually being run on top of these. So to answer the question there, what technology that needs to be done, important is kind of like choosing a more reliable, robust, and reproducible data platform in both the streaming and the batch world, and especially in the streaming world, because that's actually sort of like in most of the time, that's where your data actually started, right? So you don't actually start from kind of like a static data set. You usually want to make your data set can be more kind of like in a consistently growing and constantly growing fashion. So that's sort of like how I think about in terms of the data platform technology comparing to the ML infra technology as well. Yeah. But happy to actually dig a little bit more if there's any more questions.
We can do that. Yeah, sure. Like Neng, you can go maybe next, and like, yeah, don't be shy maybe of like mentioning some names. That's totally fine.
Okay, I saw. Yeah. So yeah, I think like in terms of discussing about what technologies we need, right? We probably need to one step back, take a one step back, and then see like what are the actual like stages in this building GenAI pipelines. So, and I think like based on kind of some of our like experience with our customers and with some research, we found that like basically there are four essential like steps in this pipeline building stuff. The first one is actually the data foundation. And the second is about model training. And the third one is the evaluation. And the last one is about orchestration. So I think since we're discussing more about real-time GenAI, so I will just focus on the data part. So for the first stage, the data foundation, and the last stage, orchestration, will probably be where like streaming technologies can be helpful here. So in terms of data foundation, it's actually very simple. How you collect data, how you pre-process your data, and how do you store your data for the late model training and the request serving. So in this phase, I think many of the important technologies is actually what we already built in the streaming world for transmitting data, for like pre-processing data with all kinds of technologies. And for storing data, mostly it's about like vector database. So there are a lot of like available options there for you to store your data with the embeddings. And for the pre-processing, it's more about how do you cleaning, chunking, and generate embeddings for those kind of data. So there are also a lot of like services available, whether that's open source or commercialized offering. And lastly, I think it's about orchestration. So for the orchestration, it's more I think there's a common like alignment that the RAG, retrieval augmented generation, is kind of the technologies we want to use to deploy our model in a production environment to offer some kind of a product offering. And with this like technology requirement, we actually need database. With the database, we actually need like embedding models. We actually need a foundational LLM models. And then we also actually need some kind of streaming pipelines to continuously like fetching data, pre-processing the data, and inject that into embedding models and send those embeddings together with the prompt to the orchestration framework. So these are the like different life cycles, and each steps there are like technologies needed to building out this actually like customer facing AI GenAI product. also with GenAI's real-time world like requirement. Yeah, there are a lot of like available choices like Kafka, like Pulsar, like Flink, like RisingWave, all those database and data streaming and data processing frameworks are available here. Yeah.
Yeah, and maybe directly to add to that, I think this was a great explanation from Neng about both the machine learning perspective with the model training and scoring and so on, and then adopt this to these different requirements like stream, process, and store. And then there's plenty of technologies you can choose from, right? And I think the big benefit of the data streaming platform, if it's event-driven architecture, is that it's truly decoupled. So it's a best-of-breed approach, and especially in generative AI, you don't know what's coming tomorrow, right? There's so many frameworks and tools, and you can choose many of them. And the other sweet spot is also you can then combine the tools like Kafka or Pulsar with Flink, and then you use a streaming database like whatever you want to choose, right, as technologies. So in addition to this kind of flexibility you only have with a streaming platform at its core, and this is a very different thing than a data lake where you persist everything at rest first, then it's already too late for real-time data, and especially for transactional data. This is where the streaming platform differs. No matter what specific technology or combination of technologies you choose for building your real-time architecture. So I think this is really the big added value here. And having said all that, still the different business units will choose different tools. Like when we talk about more research, for example, like Ron talked about a lot, I bet they use a lot of Python, right? In the production deployments, people use a lot of Java. And generative AI, often when they use a cloud service, you want to use a fully managed service with an API, and that's also fine. So this flexibility is really key. And therefore, when I talk to customers, typically we try to do the other way around. So what's your business problem and how do you want to solve that? And I think we will also talk about that. But then, and when you know your SLI requirements, your scalability requirements, your latency need, with that, then you can then choose what pieces do you need to combine to build this end-to-end generative AI platform where real-time data streaming is maybe mainly for the model scoring, but maybe also for the data ingestion into the model training wherever that happens. And so defining the business problem first is really important to choose the right tools and evaluate. And again, last but not least, also maybe then to replace parts of that over time, because you can. That's this event-driven architecture principle. You can have many consumers and they don't touch or disturb each other. The platform scales at its core. And this is why machine learning and event-driven architectures are such a perfect combination.
Thanks, Kai. Reis?
Yeah, I think a number of points raised are all valid in terms of the architecture. Like there's already established patterns that are emerging, right? But at the end of the day, the core functionality that I see as required is that one is the data integration part. Like for prompt engineering, how do you enhance that prompt through different sources of data? And that's a pure streaming problem. Like streaming engines or streaming systems like Kafka and all are the best fit for that. Now, just accessing those data sources through a set of connectors, that's one part. Then what do you do with that the raw data that's coming in from upstream sources? How do you not only ingest the data, transform it, but store it so that you can avoid having to read again and again? And I think that's where you need more like a persistence layer. And I think there you see a good case for a streaming database, so that you not only ingest the data, but you store the data. And then so that you almost have this intermediate state that allows you to not only do every request that comes in from a user is not treated as ad hoc, but rather ability to use that pre-built knowledge and data that's stored there for subsequent requests coming from users. Now, the part about embedding, creating embeddings and then storing embedding, retrieving, that's a specialized function. I think vector databases are best to handle that. I think that's another key part that I feel like is a part of the frameworks that a common pattern we're seeing. In a way, I don't see one. It's not. To me, it still seems like there's a bunch of moving parts here, where you need to look at as a customer, as a user who's implementing the solution. What sort of expertise do you have? Like, are you close to the Postgres ecosystem? Then use Postgres-based tooling to help you solve that problem. But you're coming from more streaming world. It depends on the expertise of the team in terms of what tooling you pick. So in a way, I wish there was a off-the-shelf solution that I can say, yeah, go with that, and that'll take care of all your problems. Unfortunately, that's not the answer right now. Hopefully, we will standardize to a particular pattern in the near future.
And maybe at this point, we can also add one of the first questions here, where the question is, what essential features are required in stream processing tools like RisingWave or Flink to make them really useful in GenAI tech stack? And this is really a great question, right? Because first of all, I think, because we also just heard about Postgres and so on, the reality is it's always a duality between traditional technologies and between data streaming. And that's fine, you can integrate them. And so what's happening today, I can now talk specifically for Flink, right? In Flink, where you in stream processing normally have as first-class citizens a stream and a table, where in a very big picture, right, stream is real-time messaging, and then the table is keeping the state for that. And now Flink is getting a third first-class citizen, which is the model. And so this means you see now that these open source frameworks, they directly get machine learning capabilities integrated into the framework. So this is much more than just doing a connector to something else, but really embedding the principle into its stream processing capabilities. And so this is where the streaming technologies, most of them, I think, need to get better and provide more features out of the box. Having said that, you can still do it today, right? And we have many, many customers that use machine learning and GenAI together with data streaming, as we heard. How do they do it? The reality is today, most of these integrations are still API calls. Is it good or not? Well, it depends again on your requirements. Honestly, for most use cases, using a REST API call from a stream processor, yes, it's on the one side an anti-pattern, right? Because it's not streaming anymore, it's a request response. But on the other side, it's good enough for 90% of the use cases we see today, right? Regarding scale and latency. And so it's not perfect, but it's good enough. And this is then these different trade-offs again, where you can think about, because the real world, if you do not start from scratch, and in most real world projects you don't, you need to integrate with the other side anyway, which is very often still at rest in a database or via an API call. And so on the one side, the tools like Flink and others get better with native ML integration. But on the other side, you can easily also integrate with non-real-time systems like a database or an API call. And this is in the end, so we can do both. And the trend is getting better, but you can already do it with today's capabilities.
Yeah, I think one thing I want to add is, like, the goal of with the real-time AI, is it to extend LLMs what they offer, or is it to retrain them and make them better, right? I think that's the core problem that should lead to what architecture you adopt. Because if it is the former, then I think it's a much more solved problem. Like, a lot of the people are approaching from there, because the models, if they're proprietary, you cannot retrain them anyway. So it's kind of a harder problem. If you're using an open source LLM, then the tech stack that you use is much different versus in the first case. And I think this problem is already how to enhance what tech stack. Even the big players have realized it, right? Like the OpenAI acquisition of Rockset points to that question, that how do you make it much more nimble in terms of dealing with especially the private data, like vector search capabilities with advanced indexing. Because with LLM, it's like a monolith that was built over time, older data, and it's perfect for more generic sort of use cases. Now, when you want to customize to a particular domain, you need much more advanced capabilities that are that will need to be incorporated into it. So I think that Rockset acquisition points to a direction that you can read, that how the big players are moving. Now, that's they are doing, but from a customer perspective, what sort of technologies that customers, like especially enterprise customers, can adopt to basically build on their own some sort of integration. I think that's the path forward.
So yeah, one thing I want to add is maybe a little bit in a different angle. So I think like currently while we're using like LLM models, right? You either like have some integrations calling a third party like a foundational model like OpenAI models or like AWS Bedrock models. So that is one direction, and the other direction is actually deploy your own models. So in the context of deploying your own models, right? I think for any like streaming technologies frameworks, if you want to let user to do like make predictions, generate responses to user requests, utilizing the privately deployed models, right? the ability to utilize GPU is actually a very critical part in order to improve the performance and improve the accuracy, because we know that for large language models, they mainly like rely on all these like vector calculation and stuff, right? So to my knowledge so far, like I think most of the streaming processing frameworks is still, heavily relying on CPUs, which it can still work, but not that efficient or not ideal. So if one day we can have a framework that actually can utilize GPUs efficiently, that would be kind of a very like, 10x improvement on that side to utilize the LLM models.
Any more thoughts on this? No? Okay. So I suggest we move more to challenges. Maybe we can discuss some of the challenges we're facing or we are foreseeing in the near future when building real-time GenAI applications. Like what is it? Where are the challenges? Is it like performance? Is it scalability, consistency, security, something else?
I think data quality should be at the top of the list, because I feel like when you ask a question to LLM about, just like imagine you're asking a question to Google for search, you get a bunch of answers, you curate those answers and pick the one that makes most sense, right? So the accuracy is not that big a deal. Now, consider a question from an enterprise perspective. If I want to know the bank balance, I can get an estimate. I have to get exactly to the last cent, right? Or some other mission critical application that you want to build, there is no room for error. You have to be accurate. So I think and that's not so much a problem with the model, but with what sort of data you feed to the model, providing the right context in the right window, having the up to the recent information, is sort of the key to unlocking that potential. So to me, as I read new articles about what's happening in the GenAI space, they're talking in terms of quality, but that really what they're talking underneath is how do we get the latest and greatest information to augment and to get the assurance on the predictions from LLM. And that's basically translates to a data engineering problem. And, that's where the so-called streaming world kind of meets with the GenAI world.
Yeah, I fully agree with this kind of data quality is one of the biggest challenges where data streaming can help, because the data can be always consistent and accurate. However, having said that, even before that, and this is what also Neng mentioned before about model training, right, is complex. And what people always underestimate, predictive AI is very different versus generative AI regarding best practices, model deployments, model training. So I'm pretty convinced that most, even large organizations, will not train their own ChatGPT large language models because it's so costly and complex to do that. And so the other big challenges they have is, number one, data privacy. So they need to think about, do I really do a remote procedure call to OpenAI or something else remote with my private data? Or do I host one of these open source models like Llama in my VPC or in my data center? And I think most will do more the second, honestly. And so this is the other question then, how do you deploy that, and how do you then more or less use data streaming together with vector databases and so on to really get the right context in so that you get the right answer out. So this is, I think, more what people are learning. That's the one big challenge, I think, which most organizations do not have an answer for today outside of Silicon Valley. And so that's the one thing. And the second thing, and this is related to a question we also had earlier in the chat about, how can you minimize the GPU computation? Because that's costly, right? And this is something where I think even the large language model providers still are learning and researching how much does it cost and how can we improve that? Because every query you do costs money, GPU power. And the more we integrate into automated applications, well, the cost goes up like crazy, of course. And so this is another trend where everybody's learning, not just the end user, but also the vendors, how this will work well. From a data streaming perspective, I think one answer is, and that's what we are already seeing at customers, is that use GenAI only when you need to. because it costs GPU every time. So in the example back to Expedia, I brought up in the beginning, when you have a customer service, when you use such a chatbot, it doesn't mean that it's always generative AI, but very often you can already select options like, do you want to do a refund? Do you want to do a rebooking, right? And even if you cannot just do a select box, but also add text there, this is natural language processing. This exists for 10 plus years. So this works without much GPU power. And based on that, you can design your business process. And in the end, then based on events in your architecture, to only feed the right information into a large language model when your existing NLP cannot process it the right way. And with this, then you can reduce the cost, not by reducing the compute power for ChatGPT or something, but by only asking the right questions to it. And then when you use ChatGPT today, you see if you ask the wrong question, you get very long answers. And if you don't have a premium account, the answer is very slow because ChatGPT reduces your compute power because it costs them money, right? And these are these things where there's a lot of optimizations and best practices both the end user and the vendors will learn, because in the end, the vendors pay the cloud power today, not the end user. And so I think these are the biggest two challenges I see today. And in addition to the data quality, again, it's data privacy on the one side, and it's also about the best practices for how and when to use GPU power for the cost perspective.
Thanks, Kai. Rong, your thoughts?
Yeah, so actually, I definitely agree with folks here regarding the data quality and data privacy issues. One of the things that I wanted to add a little bit different is consistency and kind of like a flexibility type of things, right? So other than data quality, one of the things that I wanted to emphasize is whether we can actually able to consistently reproduce the results that you can actually try to do in your large language model, right? So one of the examples I wanted to point out is, for example, a lot of the more advanced companies nowadays will probably trying to host kind of like a self-host solutions plus with some large language based model open source. And then they wanted to basically trying to tailor the model itself by running a lot of kind of like a supervised fine tunings or some of the instruction tunings technologies that basically utilize their own company-wide data in order to basically just tailor the model themselves. One advantage of that comparing to calling APIs, obviously, is going to be much cheaper if you know what you're doing. The second one is a lot of the times that you are actually not comfortable actually calling kind of, for example, like calling OpenAI APIs in order to basically do supervised fine tuning, because you're actually essentially handing over the data in order to basically to a non-controllable third party, right? Talk about privacy and then like security there. So if we actually set up in this kind of like specific scenarios, right? So not only just inference, also sometimes you're actually trying to tailor I'm using your data. One of the things that you want to enforce is that you should be able to consistently reproduce whatever that you're actually trying to put in, right? What we're actually seeing here is that ordering matters, data quality matters, data consistent streaming matters, right? So it's kind of like this is where a lot of the streaming solutions like Pulsar, Kafka, Pulsar, and all of these like solutions comes in, right? So they actually, in a lot of time, they provide a very stable reproducibilities when you're actually replaying the streams, right? So that's one of the things. So the second thing is like the flexibility in terms of processing, right? So a lot of time you're actually not feeding just the raw data into your large language model. What you're actually trying to do here is kind of like running some pre-processings, refinements, cleanings, even augmentation. So I see a lot of other pipelines are basically trying to use LLM to teach LLM to do some advanced things, right? But at the end of the day, your input needs to be consistent and your processing needs to be flexible, right? This is where a lot of the streaming processing engines like Flink actually comes into place. Is like it actually is consistently reproducible in either the streaming fashion and batch fashion. So you can actually rely on a single source of your coding flexibility in order to basically process both of the worlds. This is actually pretty important because if your streaming and batch engine is actually not doing the 100% the same thing, it's going to be super hard to guarantee your training results is going to be consistent, right? So in general, what I wanted to emphasize here is that in addition to privacy and data quality, one of the things that we want to enforce is consistency and flexibility in terms of reproducibilities when you're actually trying to utilize your large language model. Yeah.
Thanks, Neng. Some other challenges?
Yeah, I think it's kind of well discussed, and as summary, like we discuss about data quality, we discuss about data privacy security, and we discuss about cost effectiveness, right? I think as since we are SaaS companies, I think many people will also probably want to do some GenAI SaaS startups. I think in this area, like another thing, probably in addition to all these like different points, like this has been discussed by the panel here. I think another thing we will probably to think about is how we can maintain the flexibility of customizing a general large language model to meet like specific organizations' need. So we know that large language model is general enough that it can handle any of the general tasks. But all too often, like if we are building your GenAI applications for an organization, or you are like working with your customers, right? They have some specific needs. They have their own like specific requirement in terms of the functionalities of the final like model they see. So how in this way, how can we make sure that it's flexible enough, but at the same time, it's kind of scalable enough so to scale business? That's probably another point we want to consider. Yeah.
Yeah, I think one thing in the real time world, we are all obsessed with latency, right? I think that somehow has it come up. So not here, now I'm not speaking from the perspective of a query latency, but more from a data latency perspective, right? Especially for some of the use cases that are time sensitive. How do you ingest the data in time? How do you create embeddings in time so that in the context window within which someone is asking a question, that you can leverage the most recent data? I think that's a huge part of going to be in the future. The systems that are able to not only on the training side, incorporate the latest arriving data, just the way we do right now for non-AI use cases with streaming, right? Through materialized views and other ways that streaming databases implement that functionality. If you can incorporate the same workflows into this, that will augment the value higher and higher. Like, for example, if you are thinking about an anecdotal use case like coupons, like, or something offers you want to forward to users, it only makes sense in the context of where they are or what the pertinent information that a user has. And I think there I see a huge value for, both the PubSub architectures and event-driven architectures to really play a large role to address that latency challenge, which I feel is something just around the corner.
Thanks, Reis. Can we stop here and take a look at the questions? We have several questions in a Q&A tab and some of those in chat. So let me open Q&A tab. We have 2 questions there. So the first one is, what measures are in place to prevent data breaches or leaks in real-time GenAI systems?
Yeah, so I mean, as I mentioned before, right? So this is exactly the reason why many organizations will not actually feed their data into external GenAI platforms, right? So this is why data privacy with encryption and so on comes into mind, compliance. And therefore, I think most enterprises will use very similar scenarios and deployment and security like for their other use cases. And again, back to my Expedia use case in the beginning, they deployed the chatbot close to where all the other platforms run, like the booking system, the loyalty platform. So in the end, the requirements are not much different for GenAI from the enterprise perspective. And so regarding the data breaches and so on. And then do you share the data also with external partners? This is then if you have the right compliance agreement or whatever, right? I mean, I think also the vendors are still learning here. Like I guess that OpenAI and so on, they will provide much better solutions in the future to also be much more enterprise ready. And so in the end, the concern for GenAI, I think, is not much different compared to other platforms. And also, I mean, even like at Confluent, I mean, internally, the employees have rules, right? What they're allowed to use and what not to use. And these days, I'm not sure about your other organizations, but many people want to use things like Grammarly, right? Which support writing you a blog post or article. And then all the data you write in there is sent into the public internet in the end indirectly. And these are the rules and best practices where organizations need to do something and learn about that. But GenAI is not much different than other projects, I think, here.
Yeah, I'll have to stop you here. Okay. Any other thoughts on this one? Or we can move to the next question. Okay, let's move to the next question. How can team best prepare for the transition to incorporating GenAI into their real-time data processing workflows? Who wants to go?
Yeah, I can.
Yeah, go ahead. Right.
Yeah, I think this is again, we kind of addressed it a little bit previously when we talked about especially the tech stack to adopt, right? it has to be driven based on their use case and what their current architecture looks like, right? If they are based on a particular cloud vendor, tech stack, leveraging those elements into their workflow in terms of what options they offer for real-time processing from an ingestion perspective, from storing embeddings, from a data retrieval perspective, that should guide their transition, because there's no set path, at least in my opinion, where we can say here's the clear pattern that you can adopt, because it's still an evolving field and we don't know what the future holds. Like, as I think I was mentioning, baking in a solution or a process at this point will make you revisit again. So in some sense, starting with what you have and enhancing incrementally over time, I think that's probably the best way to move to a more real-time data processing workflow.
Neng?
Yeah. So I probably can share some of my experience because, as I mentioned in the beginning, I was more like traditional streaming infrastructure guy. So recently I started to look into the GenAI area. So I think in order to better transition from the more traditional like the real-time streaming world to a GenAI world, I think first of all, like you have to have a good understanding or like good foundation for your streaming data processing technologies, whether that's Kafka, that's Pulsar, or that's like a Spark Streaming, or that's Flink. Either way, either one. So you have to get some kind of basic understanding and then know some kind of basic concepts in the streaming world. And in addition to that, I would definitely recommend you to watch some of the YouTube videos from some of the GenAI or ML model expert to learn like what's the essential concept inside of the GenAI world, like what it actually works under the hood for like a GenAI model to generate those amazing responses. So only when you understand like some of the common languages speaking by those different communities and those different areas, you will start to form the concept of how it actually can be integrated with both sides. And a second, probably a next step would be actually looking into some kind of real world cases, whether that's as we are doing, like working with our customers together, or it's more like attending some kind of the panels like this or some kind of other meetups to learn like what people are actually trying to solve. Like you will need to get those kind of hands-on experiences in order to better understand the knowledge you learn in the step 1. And then like in the steps 3, it's more about like practice. So convert some of your existing problems, trying to like solving them using the new technologies, using GenAI models or using the data streaming technologies to express them and to solve them and see the improvements or see the enhancements here. I think in this kind of a loop, you will like gradually prepare yourself better for the GenAI, real-time GenAI streaming world. Yeah, that's my 2 cents.
You're muted.
You're unmuted.
Sorry, just trying to squeeze in a few more questions. How to gain confidence on GenAI recommendation? Do we build a digital twin of the process?
So validation is a really important topic. So I actually also see customers using data streaming as part of the post-validation, right? Because GenAI is still such a new field with a lot of hallucination. After generative AI creates something, and I don't mean a long response, but again, more about a booking or a transaction, before it's then processed through, it's validated again by a stream processor like Flink or something else, because you need to double check. And so this is a common pattern I see at many customers because they are so uncertain if the generative AI does hallucinate or not.
Any other thoughts on this one? Okay, I see some heads being nods. Okay, so let's move to the next one. What essential features are required in stream processing tools such as RisingWave and Flink to make them really useful in the GenAI tech stack?
I think we just discussed that before, right?
Yeah, it's already possible. Just the tooling gets better, right? But it's already possible, and many people use it for years in production already.
Okay. Anyone wants to add something on these essential features? We're running out of time.
Oh, I do have one personal like thinking on this one, essential features. You have to you have to provide Python APIs for people to use your technology, because as far as I learned, like nowadays the machine learning world or the GenAI world is almost all about like Python when it comes to like deploy applications or doing things. So really, like if you get a Python like API in this case, that's really an advantage here.
And maybe just to add, and I fully agree, maybe not for the where you deployed or how you deployed, but at least for the developer interface, right? Or data engineering interface. Absolutely, 100%. Yeah.
Okay,
agree.
if your questions haven't been answered, like I'll reach out to and we'll figure something out. Someone will answer your question. Many thanks everyone for joining us today. Thank you again, dear panelists. This was really super insightful. And talk to everyone next week. Bye.
Thank you.
Thanks a lot. It's great. Thank you.
Bye.
Thank you. Bye.